The following is a selected video from masterthecontent.com, where you will find an extensive video library of lectures for a variety of standardized admission tests. We offer over 600 hours of detailed video lectures for a multitude of standardized tests. Use our interactive in-lecture table of contents to find specific topics of interest. Work through numerous in-lecture examples to help you internalize concepts. To learn more, visit masterthecontent.com. Your career, our passion.
Here is we're going to look at first the treatment of an alcohol or an acid chloride with an alcohol, which is the first or one of the methods to prepare an ester, and then we're going to move on and see how we can do so or perform the same reaction using an anhydride instead. So in this case, when we're using or preparing an ester by reaction or the reaction of an acid chloride with an alcohol, the first step will be, again, a common theme, a nucleophilic addition step. Remember, that's why I told you the nucleophilic acyl substitution reaction is very important. It's pretty much what this entire lecture is about. So what happens in this case is that our alcohol will react or add to this electrophilic center of our acid chloride, our acyl halide, resulting in the formation of an intermediate that looks something like this, with a negative charge on the oxygen atom, and our alcohol is then added to the structure to form an intermediate that looks something like that. That's the first step. We're talking about a basic nucleophilic. So what happens in the next step of the reaction is that we will have a collapse of this intermediate that we just created. And that collapse will actually restore the carbonyl group and eliminate the chloride ion. So a pair of electrons will come down from that oxygen to restore or reform that carbonyl group. And then this chloride ion that we have right here will actually exit or leave with this pair of electrons right here, resulting in the formation of yet another charged intermediate that looks something like what I'm drawing at the bottom of the screen, carrying a positive charge on that oxygen atom right there. And that's pretty much going to be our second step. So it's an exit of our leaving group. It's an elimination step. And what happens next is very simple. The chloride ion that just exited or left the structure will then come along and then abstract or remove a proton. I'm talking about this proton right here. And that pair of electrons will migrate or move to that oxygen, essentially resulting in the formation of our final product, which is an ester. As you can see, we have our ester looking like that. That's our ester, and obviously we are going to have our hydrochloric acid byproduct. So it's a very simple reaction. Again, this is basically an addition elimination step. It's basically a nucleophilic acyl addition reaction. What happens initially is after addition has occurred, our intermediate will then collapse to restore the carbonyl group and eliminate the leaving group, which then deprotonates that intermediate to form our final product. So let's go over that one more time. Again, you have a nucleophilic addition step, and that nucleophilic addition step is actually going to result in the formation of our intermediate right here. Then a pair of electron migrations, one from that oxygen to restore, reform that double bond, and one to eliminate that chloride ion then occurs, resulting in the formation of the intermediate that we have at the bottom right-hand corner of the screen. Now this reaction is then completed when this chloride ion that was only just eliminated comes about and abstracts or removes a proton. I'm talking about this proton right here, resulting in the formation of our final product, our ester.